Hi everyone, welcome back to the channel. If you are new here, my name is Tracy, your Elixir mentor and coding buddy. In our previous video, we explored 3 key features that make the Elixir Supervisor essential for building fault-tolerant and robust applications. In our previous video, we explored 3 key features that makes the Elixir Supervisor essential for building fault-tolerant and robust applications. We mentioned that a supervisor can start a process, can restart a process in case of a crash, and can isolate a process that has been affected so that it doesn't take the whole application down with it. In this session, we are going to see the supervisor in action. Remember our Customer Tracker server, the GenServer process that we created to track the number of customers who are entering and who are leaving our imaginary restaurant. So today we are going to assign it a manager who is the supervisor. Let's start by first understanding the diagram presented here. This diagram represents a supervision tree. At the top of the supervision tree, we have the supervisor process. Under the supervisor process, we have 2 child processes, process A and process B. These 2 processes are managed by the supervisor process, and this is exactly what we want to achieve. We want to start a supervisor process that will supervise 1 or more processes. We can now spin up the interactive shell under the tracker application and start the supervisor process that will be responsible for our customer tracker server. So I'll just write ix-s mix command. We are going to start the supervisor process directly using the supervisor start link function of RET2. This function takes in 2 arguments. The first argument is the children, and the second argument is a list of options. The list of children that we are passing to the start link function as the first argument defines the child specification that describes how the supervisor is going to handle the child processes. This is how it describes how the supervisor can start the child process or shut down the child process or restart the child process. The child specification is passed as a map format and it contains 6 elements or 6 keys. That is the ID, the start, the restart, and the type key. But only 2 of the keys are required, that is the ID and the start. We are going to define our child specification using those 2 required keys at the moment. Let's define the child specification. I'll pass the variable children here, which is passed as a list. So inside the list, it's where we're defining the child specification. I will use only the ID and the start key. So the ID is the unique identifier that the supervisor will use to identify the child process. We can pass this as the customer tracker server module name. The second key I'm passing is the start key. This is the key that will help the supervisor know which child process to start. It's passed in a tuple format. Inside the tuple format, it takes in the module, the function, and the argument element. The first element we are passing is the module. So we intend to start the customer tracker process, and to start it, we need to call the start link function inside the customer tracker. That is the customer tracker server. The second element is the start link, and the third element is the argument. We can ignore the argument now because if we don't pass, it will still default to the argument that is passed inside the start link. Pass an empty list. The second argument that we are passing to the supervisor start link function is the list of options. In the options, we have the strategy option. The strategy option is the one that tells the supervisor how to manage the failed process. This includes the 1-for-1 strategy. The 1-for-1 strategy, if a process fails, the supervisor only restarts that process that has failed. Then we have the 1-for-all strategy. In this strategy, if a process fails, the supervisor will restart all the processes, including the ones that are not affected. For example, if we have process A, process B, and process C, and process B fails, the supervisor restarts all the processes here, process A, B, and C. Then we have the rest for one strategy. In this strategy, if a process fails, let's say process B, the supervisor will restart process B, the one that is affected, and also restart the rest of the process that follows after process B. If we have process A, B, C, and D, and process B is affected, the supervisor restarts process B and also restarts process C and D. The second option we have is the max restarts. This defines the maximum number of restarts that is allowed in a given time frame. The default maximum restart number we have is 3, and this is where we also need to be careful when defining a GenServer process. Let's say, for example, we have a GenServer process that keeps on terminating, and this GenServer process is supervised by the main supervisor of the application, which also supervises other processes. If this GenServer process keeps on terminating and the supervisor keeps on restarting this process, once the max restart is exhausted, the supervisor can also be terminated. And if the supervisor is terminated, that means all other processes will be affected and the whole application will go down with it. The other option we have is the max seconds. This is the time frame in which the max restarts applies. It defaults to 5 seconds. Then we have the name option. This is the one that you can use to register the supervisor by giving it a name. Among the options that have been mentioned, only the strategy is required. Now let's go ahead and start our supervisor. To ensure that our supervisor has started successfully, I'm pattern matching with an OK PID as the expected output. Then we call supervisor startLink function, pass it the list of children that we have just defined, and also pass the strategy option. So we are going to use 1-for-1 strategy. We now have our supervisor started. Let's investigate what's happening within the supervisor. We're going to use the process identifier for the supervisor, that is the PID. Let's call supervisor count children function and pass it the PID. It has returned a map which has some information within it. The number of active children within the supervisor is 1. The number of workers is also 1. So the worker here refers to the child process, which is the Customer Tracker server process. The number of child supervisors supervised by our supervisor is 0. There's no child supervisor. And the number of specification we have, this includes the total count of children within our supervisor, that is the specs. It's also 1. This one refers to the Customer Tracker server that has been started under our supervisor. We only have one process under our supervisor. Let's investigate further to see if we can get more information about this supervisor. I'm trying to see if we can get the information of the child process started by the supervisor. Let's use the which children and also pass it the PID. Yeah, we now have at least more information about it. You can see the information of the worker that has been started under the supervisor, and also we have the PID of the Customer Tracker server process. I'm going to define this PID of the worker. Let me call it worker PID. I just want to get hold of this PID and see if we can perform some tasks within it. Call the PID kernel function, pass it 0, 146 and 0. Yeah, so we have gotten hold of that PID. Now, if we want to add a customer, I can call the add or remove customer function. Let me take the customer tracker.add or remove customer, pass it to the PID, then the request message that the server will listen to. This is the request message. The number of customers is an integer number. We can add maybe 3 customers. Something is wrong within our server. No function clause matching in supervisor handle cast. The state, this is the PID of the customer tracker or the... I have passed the wrong PID. The PID I've passed here is the supervisor process and not our worker PID. The other thing you can notice here, I've introduced a crash. I want to see if our worker process is still alive. That is the worker PID. Seems not to be alive. The interactive shell has been restarted. I will need to start the process again, the whole process. We now have the PID of the child process. Let's see if we can interact with it. What I will do is add or remove the customer within our customer tracker. Call customer tracker, add or remove customer, pass it the worker PID. Then the message, the request message that the server is expecting. This is the request message, that is add customer and pass it an integer number, or maybe pass it a number 3. We have added the customers. Let's see if it's actually added by retrieving that information. We can retrieve by getting the number of customers. Call customer tracker server and we call the function get customer number. Then pass it the request is expecting, that is get customer number. This function is get customer number, or text in the PID. I've passed it with an RT argument, that is the worker PID. And you can see the information being displayed here. Current customer number is 3 and the time is that. That means our child process was started successfully by the supervisor. What will happen if we introduce an error within our server? In this case, we're expecting the supervisor to restart the child process that has been affected. Let's say if that will be the case with our demonstration. Demonstration can also go in a different direction that we don't expect. So let's say if that will happen. We already have our worker PID. In here, an error will be raised. I've just called raise with an intentional error. I want to see if that will be the case or I will have to restart it. I'm going to add customers. Maybe change that to 1. When it's trying to handle the add customer requests, it's going to raise an error. We have an error raised, and here you can see the PID 0158.0 terminating. Let's confirm if that is our worker PID. That is our worker PID. We have a runtime error and has been raised at line 25. That is the same place that we have introduced the error. I want to see if there's any child process that is under our supervisor that is active, and also I want to see if this worker PID is still alive. I don't expect it to be alive. By the supervisor restarting a child process, it means it's starting a new process. Let's see if this is alive, which I don't expect it to be alive. That's okay. Now let's see if there's any child process within our supervisor by calling supervisor. This seems like a long process. Let me just type it. Supervisor count children and pass it the PID. The PID here is the supervisor PID. We have 1 active children, 1 worker. So if you have 1 active child, this means that there is 1 child that is alive. Let's see the new PID of the child process that has been started by calling the supervisor which children. Just pass it the PID again. We have a new process that the supervisor has started. It's working as we expected. Now let's see the isolation in action. What I want to do is start 2 child process under our supervisor. So we are going to start a new supervisor with 2 child process. I want to clear this. I'll define a new child specification just with the same format, the ID, but now I want to use an ID that will differentiate the 2 children. Maybe let me pass an atom. Then use the start. We are starting the customer tracker process. I'll just call the start link function again, pass it the default argument. So that is the first child specification. Add another one. This will pass with an ID 2. The same thing because it's the same. We are passing the server but with a different ID that will differentiate between the 2 child process. That is the start link. And then the arguments. Here we have that. I've closed. I need to close the first map of the child specification. No, that's okay. I can go ahead and start the supervisor. There's a start link function. Pass it the new list of children and the option. If you don't pass the strategy option, it will raise because it's a required option. That is 1 for 1. Now we have started a new supervisor with 2 children under it. Let's get the PID of the workers. We can do that by just using the function with children, then pass it the PID, and we have them here. We can call it worker PID1. I'm just using the kernel function, and then let's have the worker PID2. that is 174. I want to interact with the first worker, which definitely will fail because of the raised error. Then see if the second worker will still be alive. Let's do that by calling the Customer Tracker server and add or remove customers. Pass it the worker PID1, then the request message, that is add customers. Replace this with a number, maybe 4. This is worker PID1, which is going to have an error. So we don't expect the worker PID1 to be alive. We expect that the supervisor might have restarted another child process to replace the first worker, and we expect the second worker to be alive. Let's see if the second worker is alive, because the supervisor has the ability to isolate crash. Worker PID2, it's still alive. That means that our supervisor has been able to isolate the crash. What has happened to the first process has not affected the second process. We can also check how many child processes are alive within our supervisor. You can use the count children to check that. We have 2 processes that are alive. Let's see which children are under it. We have 2 children, and you can see that we have now a different PID from what we had with the first child process. So this is another process that has been started. The ID that we passed still matches what we had defined in the child specification. In every Elixir application, there is the application.ex file. In this file, we have the main supervisor already defined for you. If you check in here, we have the start function, which takes in the 2 arguments, and inside it we have the children, which expects the child specification to be passed inside the list. And we have the option where the strategy of 1-for-1 is passed, and also the main supervisor has a name registered for it, which is the tracker supervisor. When you start your application, the supervisor start link function is going to be invoked, and it will start the supervisor, and the supervisor will in turn start the child under it. Let's start the main application and then investigate the main supervisor. We have started our application by just calling ax-sme. Then we can check the information within the main supervisor. Let's call which children to see if there are any children, though we don't expect any child to be started by the main supervisor. It's empty. If we call count children, you can see that there is no active child process, neither there is no worker, there are no supervisor child process. The specs defines the total count of processes under the supervisor. The count is still 0. In our first example, we started the supervisor directly by calling the supervisor start link function in the interactive shell. You can also start a child process by passing it as a child of the main supervisor. To start the customer tracker server under the tracker supervisor, we can specify it under this list. Just call the customer tracker server here. You can pass it as a tuple of a module and the arguments, and also you can pass it as a map format, the way we defined the child specification earlier. So I'll just pass it as a module. For the changes to be picked up, I will have to restart the interactive shell. Again, we can now investigate the tracker supervisor to see if it has a child process under it. I'll just call which children and pass the tracker supervisor. You can see it has 1 child process, and this is the PID of our customer tracker process. To recap, we have been able to start our supervisor directly by calling the supervisor start link function. We have also seen the supervisor in action, how it can start a child process, how it can restart a child process in case of a crash, and how it can insulate a crash from affecting another process. We have also seen that it's possible to start a child process under the main supervisor by just passing the module name under the children list in the application.ex file. In our next video, we shall look at other types of supervisors that you can define in your application, that is the module-based supervisor, the dynamic supervisor, and the partition supervisor. That's it for this session. In case of any question, feel free to drop it in the comment section below. Until next time, see you.